Hello everyone, this is your course instructor Harshita. So in second module, after Shannon encoding algorithm, we've got to study about Shannon Fano encoding algorithm. So now let's consider an example and just see how it is different from Shannon encoding algorithm and what are the set of procedures that we are supposed to follow while solving the problem that is based on Shannon Fano encoding algorithm. So the given problem is given the messages with their probabilities, construct a binary code by applying Shannon-Fano encoding procedure. Determine the code efficiency and redundancy of the code. Also draw the code tree. The probabilities set are given as zero point 0.2, zero point 0.2, zero point 0.4, 0.03, 0.07, zero point 0.1. The symbol set is S1, S2, S3, S4, S5 and S6. The first step that you're supposed to do is the same that we followed for the Shannon encoding algorithm, that is arrangement of the given probabilities in descending order. So first I'll be arranging the probabilities in descending order. The highest value here is 0.4. Next highest value is 0.2, so it is twice, so I'll write 0.2 and 0.2. Next highest value is 0.1. After that it is 0.07 and 0.03. So after this, what I'm supposed to do is I'm supposed to group. So based on what am I going to do the grouping? What is the logic that I'm going to use in order to group the probabilities? So I use this logic such that the sum of the probabilities in each group is approximately equal to the other group. So here you can see that first and the second value is 0.4 and 0.2. So after adding that I'll get 0.6. So now here I have 0.2, 0.1, 0.07 and 0.03. So after adding all these I'll be getting 0.4. So this 0.4 is approximately equal to 0.6. So what I'll do is this 0.4 and 0.2 I'll group it. So this is known as first subgroup, and next the last set of 4 values I'll group it and call that as second subgroup. So after grouping, the next step that I'm going to do is assigning of 1 and 0 for subgroup 1 and subgroup 2 respectively. So what I do is for subgroup 1 I'll assign the value 1. For subgroup 2 I'll assign the value 0. Next I need to follow the same procedure, that is subgrouping, assignment of ones and zeros. So here this can be subgrouped, isn't it? So there are two values 0.4 and 0.2. There is no other way of grouping since there are two elements. This first element is first subgroup, second element 0.2 is second subgroup. So 0.4 is first subgroup, 0.2 is second subgroup. So I'll be assigning 1 and 0 for subgroup 1 and 2 respectively. So I'll write 1 and 0 here. Next, this is a second subgroup. Now I'll have to divide this into subgroups further. So how will I do that? First add these two values 0.03 and 0.07. I'll be getting 0.1. Am I right? So next I have got 0.1 by adding these two values. Now I have one more 0.1. So let me add that. So I'll get 0.2, isn't it? So I already have 0.2 here. By adding all these three values, that is 0.1, 0.07 and 0.3, I got 0.2, right? So the sum of these three probabilities is equal to this probability alone. So what I'll do is I'll apply this logic, that is sum of the probabilities is approximately equal. So this 0.2 is first subgroup and all these three probabilities will form the second subgroup. After dividing, I'll be assigning 1 and 0. So 0.2 I'll be assigning 1, 0.1, 0.07 and 0.03 I'll be assigning it with 0. Next, this 0.4, 0.2 and 0.2 I cannot divide it into subgroup further, so I'll leave it as it is. Next, only thing that I can divide it into subgroups is this group, that is 0.1, 0.07 and 0.03, isn't it? So next, how do I go with grouping for this? So let me first add 0.03 and 0.07. Okay, I'll be getting 0.1. Now I already have 0.1 here. So this 0.1 is one group, and this 0.7, 0.07 and 0.03 is another subgroup. So this 0.1 is assigned with the value 1, and 0.07 and 0.03 is assigned with the value 0, because you're supposed to assign the value 1 and 0 for subgroup 1 and 2 respectively. Next, this 0.1 cannot be divided into subgroups further, so I leave it as it is. The only thing that can be divided into subgroups is this group that has 0.07 and 0.03. So there is no other way of using that logic, that is sum of the probabilities should all approximately be equal. Since there are only two elements, first element will form subgroup 1, second element will form subgroup 2. So this 0.07 and 0.03 subgroup 1 and 2. So I'm assigning 1 and 0 respectively for that. After this, what I do is I'll write a tabular column with two columns. First column is code words, second column is length. So for how will I write the code words for this? All of you please observe this first row. The bits that I've assigned is itself the code word. Okay, so in first row you can find bits 1 and 1. So this 1 and 1 is the code word for symbol 1 with probability 0.4. Is it alright? So 1 1 is the code word for symbol 1, and the length is 2 because there are 2 bits in this code word. Next, second row, please observe. I have 1 and 0. So 1 0 is the code word for symbol 2 with the length 2. Next, third row. If you can observe, I have 0 and 1. So I'll write 0 and 1 with the length 2. Next, in the fourth row, I have 0 0 and 1. So 0 0 1 is the code word for symbol 4 with length 3 because there are 3 bits. Next here, if you can see, 0001 I have. So 0001 is the code word for symbol 5 with length 4. Similarly, for symbol 6, 0000 is the code word with length 4. Next, in the similar way, as we calculated average length, entropy and efficiency for the problem with Shannon encoding algorithm, the same formula we are supposed to use and calculate average length, entropy and efficiency, and also the redundancy. Is it all right? The formula for average length is L equal to summation of I equal to 1 to 6 because there are 6 symbols, and a product of probability and the length. Probability is here and the length is here in this column. Okay, substituting the values, we'll be getting L equal to 2.3 bits per symbol, and the entropy formula is summation of I equal to 1 to 6 pi log 1 by pi to base 2. So by substituting the probability value, we'll be getting this expression, and by calculating with the help of calculator, you'll get entropy as equal to 2.209 bits per symbol. Next is efficiency, which is nothing but the ratio of the entropy and the length, that is the average length. So by substituting the values of the two, you'll be getting efficiency as 96.04, and the formula for redundancy is 1 minus eta c. So if you substitute the value of efficiency that you've already got, we'll be getting redundancy as 3.96%. Next, if you go back to this question, the second part of the sub question is we are supposed to draw the code tree. So how will we draw the code tree? By looking at this code words, we'll be drawing the code tree. So first I'll be drawing the root node S. Okay, and I'll be branching this node into 0 and 1. Left side I'll be writing 0, right side I'll be writing 1, and further I'll be getting two nodes. This node is also branched into 0 and 1. 0 I'll be branching it towards left, 1 I'll be branching it towards right. So like that, based upon the code word, I'll be going with the branching. So first code word is 1 and 1. That is for symbol 1. So first I write root node 0 and 1 are the branches. First one I got it here. Next also I have 1. So I'll branch this 0 towards the left side and 1 towards the right side. So from the root node, if I traverse this path, I got 1 and 1. So that is nothing but the code word of symbol 1. So I'll terminate the branching at this node and write as 1. If you go back to this table and see, the code word for symbol 2 is 1 and 0. So first one I've got it here, and the second 0 I'm getting it here. Okay, so that by traversing in this path I'll be getting 1 and 0. So at this node I'll be terminating the branching. I write it as S2. If you can see, the code word for the last symbol, that is S6, is 0000. So it all comes towards the left side itself. So based upon the code, I'll be going with the branching. Okay, so as and when I complete the code, I'll be terminating the branching. So I've already got 4 zeros here. I'll terminate and write S6. So similarly, I'll write the branching and terminate at the required point for S3, S4 and S5, and I'll get the code tree like this. Thank you all.